Hi students, in continuation of inverse Laplace transformation problems by partial fractions, today we are going to discuss the problems inverse Laplace transformation problems by convolution theorem. Okay, so what is meant by convolution? Let f of x, f of t and g of t, f of t and g of t, okay, two continuous functions, then convolution between f of t and g of t. Okay, the convolution between f of t and g of t is defined by f of t star. Star indicates a convolution. Okay, g of t. Okay, so f of t star g of t means convolution between f of t and g of t is defined by integral 0 to t f of u g of t minus u du. F of u g of t minus u du. Okay, here why the convolution is helped here. So for finding inverse Laplace transformations, we are applying convolution theorem. Okay, so using convolution theorem, okay, L of, let's suppose Laplace transformation of f of t equal to capital F of s, and Laplace transformation of g of t equal to g of capital G of s. Then inverse Laplace transformation of f of t into g of t is equal to convolution between f and g. Okay, this is nothing but called theorem, convolution theorem. Using convolution theorem, okay, so we are finding inverse Laplace transformation. Now the statement is, suppose Laplace transformation f of t equal to f of s and L of g of t equal to g of s, then inverse Laplace transformation of f of t, inverse Laplace transformation of capital F of s and g of s is equal to convolution. Okay, convolution between f and g. So f and g is equal to integral 0 to t f of u g of t minus u du. Okay, so the properties of convolution theorem, f star g is nothing but g star f. That means again you can also write integral 0 to t g of u f of t minus u du. Okay, 0 to t g of u f of t minus u du. Okay, so whatever it is, so depending on the problem you can choose f and g. Using convolution theorem to evaluate L inverse of 1 by s into s square plus 2s plus 2. Okay, so write 1 by s into s square plus 2s plus 2 is equal to 1 by s into, you observe here, s square plus 2s plus 2 can be written as s square plus 2s plus 1. That means s plus 1 whole square, s plus 1 whole square plus 1 formula. Okay, so this is equal to 1 by s into 1 by s plus 1 whole square plus 1. So say first one is f of s into g of s. Okay, so here you take f of s equal to 1 by s. F of s means inverse Laplace transformation of Laplace transformation of f of t. Okay, so this is equal to f of s equal to 1 by s. So f of t equal to L inverse of 1 by s. L inverse of 1 by s means 1. Similarly, g of s equal to 1 by s plus 1 whole square plus 1. Okay, that means Laplace transformation of g of t equal to g of s equal to 1 by s plus 1 whole square plus 1. Okay, so implies g of t equal to L inverse of 1 by s plus 1 whole square plus 1. Okay, so here you observe s is shifted to s plus 1. Okay, so e to the power of minus t into L inverse of 1 by s square plus 1 e power minus t into sin t. Okay, therefore we have f of t equal to, okay, 1 and g of t equal to e power minus t into sin t. Okay, so using convolution theorem, L inverse of f of s into g of s equal to, okay, convolution between f and t. So f star into g star. F star into g. So this is equal to integral 0 to t. Okay. So you apply convolution e power f of t and g of t means f of u and g of t minus u du. Okay, either you apply f of u, g of t minus u, or you write integral 0 to t, okay, g of u, f of t minus u du. Okay, so here you observe f of t value is 1. So that I am minimizing the term t minus u. Okay, so f of t equal to 1, so that I am taking g star f formula. So this is equal to, again this is equal to, here I am taking integral 0 to t g of u. G of u means e to the power of minus u sin u into f of t minus u means f of t value is 1. So its value is 1. 1 into du. Okay, you need not write t minus u whole power 0. This is the t to the power of 0, so that t minus u whole power 0, nothing but 1. Okay, integral 0 to t e to the power of minus u sin u. So we know integral e power at sin bt equal to e power at by a square plus b square of a sin bt minus b cos bt. Okay, so use the formula here, a equal to minus 1 and b equal to plus 1. Okay, so it is equal to e to the power of minus u by a square plus b square and minus 1 square plus 1 square. Okay, of a means minus 1 into sin u minus cos u, 1 into cos u. Okay, within boundary 0 to t. So that it is equal to e to the power of minus t by 2 minus sin t minus cos t. Okay, minus e to the power of 0 by 2 sin 0 0. Okay, minus cos 0 is 1. So 1 by 2 common, 1 by 2 common, 1 by 2 common, and it is minus 1 and minus of minus plus 1. So take plus 1 and minus take minus as common, e to the power of minus t into sin t plus cos t. Okay, so 1 by 2 into 1 minus e power minus t into sin t plus cos t is the required inverse Laplace transformation of 1 by s into s square plus 2s plus 2.